As with all good programming languages, Java supports the use of variables to store data in memory. There are two major types of variables in Java, known as primitives and complex objects. Primitive variables are stored in the fastest possible memory, but there's a very small number of data types that you can store this way. They include numeric values, such as integers and floating decimals, single characters, not complete strings, and Boolean values, variables that equate to either true or false. These values can be stored as primitive values, and so they're placed in memory and they can be accessed very, very fast. Everything else that you might want to store in memory in a Java application is going to be represented as a complex object. You declare a complex object as an instance of a Java class. Here are some data types that you might think of as simple values, depending on what languages you might have used before, but in Java are complex. These include strings. Any string value longer than a single character must be stored as a complex object and not as a primitive. Date values, which can be interpreted as numeric values, the number of ticks from a particular date, but in terms of Java memory management are stored as complex objects, and everything else that you might want to work with. As I've mentioned previously, pretty much everything in Java is an object of some kind. So how do you actually declare a variable in your code? The syntax looks very similar regardless of whether you're working with a primitive or a complex object, but there is a significant syntactical difference. Let's look at primitives first. You declare your variables in three parts. The first part is the data type. Every variable that you declare in Java has to be declared with its data type, and once the data type is set, it can't be changed. This is how the Java virtual machine determines how much memory needs to be allocated. The second part is the variable name. Variable names in Java always start with a lowercase initial character, which can be an alphabetical value or an underscore, but not a numeric. These two parts are required. The third part is optional, and it's the initial value of the variable. Here's a classic primitive variable declaration. Int new variable equals 10. The first part is the data type. int stands for integer, so you're declaring the variable as an integer, and you'll only be allocating enough memory to store an integer. You can't just magically change this variable at runtime and turn it into, say, a double or a float. It's always going to be an integer. The second part of the variable declaration is the name. The name of the variable can't have any spaces or other special characters in it, and the initial character has to be either alphabetical or an underscore character. It can't be a number. The length of the variable name is up to you, but I recommend that you name the variables so that they mean something to you as a developer. You'll see variables named I or X in very limited scopes, but if a variable is going to stick around and be useful in your application, give it a name that matters. The last part of the declaration is optional. This is the assignment of the initial value. You use the equals operator, which is the assignment operator, and you pass in a value that's compatible with the data type that you declared. The value 10 in this context is a literal integer, so I'm assigning the value of 10 to the integer, and while I can change the value of new variable later on, the value I assign later also has to be an integer. If you leave the assignment off, then the primitive variable will have its default value. For numerics, that's always 0. For Booleans, it's false. Now let's take a look at how you declare a complex object. The declaration of a variable as a complex object, once again, is an instance of a class. As with primitives, you declare them in three parts: the required data type and required variable name, and then the optional assignment of the initial value. When you set the value of a complex object, you use the new keyword and a particular kind of function or method called the constructor method of the class. The name of the constructor method matches the name of the class. So if you're declaring something is a string, then you're going to use a method named string. Here's what the code looks like. Once again, it'll have the data type and the variable name, and then optionally the initialization. The first part of this declaration is the data type. I'm referring to a class. How do I know this is a class and not a primitive? Well, primitive data types are always all lowercase. So int, double, float, Boolean, and so on. They'll be spelled all lowercase. When you see a data type with an initial uppercase character, Now you're talking about a class, and you know you're working with a complex object. The variable name, once again, goes second, and the conventions for naming complex object variables is the same as for primitives. The initial character must be an alphabetical character or an underscore. You can't use numbers for the first character, and by very strong convention, it's lowercase. You can use uppercase characters in the middle, a syntax we sometimes call camel case, to make it more readable. The optional assignment looks like this. As with primitives, you use the equals assignment operator, but now because you're creating an instance of a class, you use the new keyword and you call the constructor method of the class, which matches the name of the class. Some constructor methods are called without passing any values in, and some constructor methods are called and you have to pass values in. And in some cases, it's optional. You'll look at the API documentation for the class you want to use to figure out what the right syntax is. For complex object variables, if you eliminate the assignment, the variable name will exist, but it won't point to anything in memory. And we say that that variable has a value of null, N-U-L-L. And I'll show how to deal with null values later in the course. When you declare a variable, it's important to know what its scope and lifetime is. You can either declare a variable inside a function or method, or you can declare it outside the function as a part of the class. When you declare the variable inside the function, the variable is local to the function, and when the function is finished executing, the variable goes away. It's no longer available. We call it being dereferenced. Here's an example of a string variable which is declared inside a function or method called doSomething. The data type is string, the name of the variable is say hello, and it's an instance of the string class with the value hello. This code works fine because I'm referencing a variable that was declared inside the same function in which I'm trying to output it. But let's take a look at a bit of code that doesn't work so well. In the function doSomethingElse, I'm once again declaring a variable and giving it an initial value of hello. But then I try to reference that variable in code that's outside the function. Because the variable was declared inside the function, it is not available to code outside the function. It can only be referenced inside the function. And when you type this code and try to save your application, you'll get a compile time error. If you're working in Eclipse, you'll see something in the problems view that says, I don't know what that variable is. It's not in scope. There are times when you want variables to be available to more than one function or method at the same time. And there are a few different ways of doing this. One of the most popular is to use something called a class variable, known officially in Java as a field. When you declare a variable outside of the function, it belongs to the whole class, and it can be referenced by any function within the class. Here's an example. I'm declaring a class called myClass. Notice that this time I don't have a main method, so this is not a class that's starting up the whole application. Within the class, I'm declaring a variable and giving it a data type of string, a name of say hello, and once again an initial value. The function doSomething can reference that variable because the function and the variable are both members of the class. As long as the method and the variable are both part of the same class, the method can reference the variable and use its value. So once again, this kind of variable is officially called a field in Java. You'll also hear it referred to sometimes as a class variable, but the two phrases mean the same thing, class variable and field. And if you look at the documentation for the classes in the Java class library, you'll see that this type of variable is referred to as a field in the API docs. So that's a brief look at how to declare variables and a little bit about the differences between primitives and complex objects. In the next video, we'll do some exercises in Eclipse, where we declare some variables and output their values using the system.out.println syntax.